Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also, click on bell icon to receive latest lectures as and when it is uploaded in my channel. Now let's start the session number 31, which is based on pump unloading circuit. Now what is called as pressure unloading valve? First we will understand, then we will proceed further. Pressure unloading valve. A pressure unloading valve unloads the fluid energy at a lower pressure, whereas a pressure relief valve requires full system pressure to unload the energy, which results in high quantity of energy loss. Pump unloading circuit. An unloading circuit is built when a pump outlet is to be diverted to the tank at a low pressure during part of the cycle. This may be necessary when load conditions exceed the available input power or to avoid wasting of power or generation of heat during idle periods. Now, to understand more clearly, we will discuss the concept of double pump or dual pump hydraulic system. In most of the hydraulic applications, an operation requires low pressure, high flow initially, followed by high pressure and low flow. High flow is for higher velocity and higher speed of the actuator, and low pressure to overcome friction during a part of initial operation, and low flow and high pressure for low speed and high force on the actuator. Some of the common hydraulic machine operations which you can see in this figure. Such situation is true where ram moves faster in initial stage followed by slower motion. Such operations are common in hydraulic clamping, hydraulic forming, bending, shearing, etc., which you can see on the figure on the right hand side of the slide. Such operations can be carried out with the help of a variable displacement and variable torque hydraulic pump. This can be easily achieved with the help of two pumps with common electric motor, which you can see in the figure on the right hand side. Pump P1 is a low volume high pressure and pump P2 is a high volume and low pressure driven by a common electric motor. Associated with these two pumps are two pressure relief valves R1 and R2 respectively, and a check valve represented by CV. The relief valve R2 is operated by the pressure of P2 and R1 by the pressure of P1. During the initial clamping operation, where the ram has to move faster with less force, that is, more flow and low pressure. Both the relief valves are closed and both the pump deliver fluid to the load, majority coming from P2 since it is of higher capacity. At the final gripping or clamping or machining operation, the relief valve R2 opens, causing all the fluid from P2 to return to tank, and the pressure at A falls to a low value. Check valve stops fluid from pump P2 and delivered to tank via R2. Consequently, the pressure rises at B to the level set by the relief valve R2. Such type of systems are manufactured as a single unit with motor, pumps, relief valves and check valve incorporated in the unit. This should not be confused with the sequencing of cylinders of operation. Next concept we need to discuss is called as counterbalancing circuit using a counterbalancing valve. The figure shows the same. Now, just now we have discussed that a counterbalancing valve is used to prevent or to control the free fall of a vertical cylinder due to gravity. Now, the figure shows a hydraulic circuit to control a double acting, that is nothing but differential type, using a counterbalancing valve when the pump delivery is directed to the upper side of the cylinder through port A of the valve, which you can see the position 1 in the figure. The cylinder is forced down, causing pressure at the primary port represented by PP of the counterbalance valve, that is nothing but back pressure valve, to increase and raise the spool, opening the flow path for discharge through the secondary port of the counterbalance valve through the 4/3 DC valve and subsequently to the tank. In second position of the DC valve, that is position number 2, the cylinder is held in the raised position, and in third position, the cylinder is raised carrying the load. Then coming to the next concept, that is called as sequence circuits of hydraulic cylinders using two sequence valve. A sequence valve is a pressure operated valve which at its setting diverts flow to secondary line while holding the predetermined minimum pressure in the primary line. A sequence valve is used in a hydraulic system to carry out various operations in a sequential order, that is, one after another. Sequence valve has been going to be explained in the next coming chapters in detail. Now the figure shows on the right hand side, which is a hydraulic circuit for sequencing of two cylinder using a sequence valve in conjunction with the directional control valve. The operations are clamping of job and machining the same. When the first cylinder extends to a right, it clamps the job with the help of a power-wise job. Extension of cylinder 2 takes place when the fluid from the sequence valve is directed to it. This extension is used to operate a power vise to hold the job. Now let us understand how does it work. The 4/2 DC valve is shifted from normal position to the actuated position. Then high pressure oil enters the head end of the cylinder 1 and extends the same, during which low pressure oil on the rod inside of the cylinder 1 flow through the check valve, that is CV2 of the sequence valve, SV2 to the tank port B and T in the figure. At the end of the extension of the cylinder C1, the pressure of oil increases and flows to the head end of the cylinder 2 through sequence valve 1. Next, at the end of extension cylinder 2, that is nothing but C2, the valve is shifted to normal position, which results in connection of ports A to T and P to B. Again, high pressure oil enters the rod end of the cylinder C2 and retracts the same, and low pressure oil from head end of the cylinder C2 flows through check valve 1 of sequence valve 1 and to the ports A and T. And at last, at the end of retraction, C2 pressure increases and high pressure oil enter the rod end of the cylinder 1 through sequential valve 2 and retracts the cylinder, during which low pressure oil on the head end side of the cylinders flows back to the tank through the ports A and T. Now sequencing can also be performed using one sequence valve, provided the sequence of retraction of cylinder is immaterial. But by using two sequence valve, even retraction is sequenced in reverse, that is, C2 is followed by C1 and the respective pressure variation in the cylinder during the sequence operations can be seen in this particular slide. Now the time allotted for this session has been completed. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Talandan.